Okay, so think of parallels as the parentheses in a math equation, and I'm going to show you what I mean by that. If you have, actually, if I can select pencil here, if you have 2 times 5 plus 7, sorry, I'm drawing the mouse, plus 3 times 1 plus 2, you have to solve these parallel first. So obviously, are these parentheses first. Same here with this parallel. And then ultimately, you're going to have a series here and a series here that you got to do. And then those two series values are going to be in parallel. So parallel is the parentheses um, of Ohm's law. So I'm going to do an undo and get rid of all of this extra stuff. But I'm going to not do this circuit for you, but I'm going to kind of explain how you would. So the very first thing I would solve is this because it's a parallel within a parallel. So what you're going to end up with is your same source here. You're going to end up with R1. You end up with R2. Oops, I don't know why it's undoing. Let's try that again. End up with R1. End up with R2. R3 right here. So this is exactly the same as this. Now you're going to solve just that parallel branch of 50 in parallel with 100, and you're still going to have your 25 down here. So let's do some circles here. So this is now just that one value of those two in parallel. So it'd be 50 in parallel with 100, which is going to be something less than 50. Again, not going to solve that for you. I'm going to let you do it. Then I've got to add these two, and oops, I see I left out a resistor down here. Let's add him in. So my bad there. So there is also one down here. So everything's the same except I have solved this parallel branch, placed its value there. Now I'm going to add these two together because they're in series. Then I'm going to add these two together, and I'm going to come out with a circuit that looks like this. It's going to have just this one parallel branch here. So let's use some colors here as well. So these two are now added together to get this. These two are added together to get this. Then we're going to have to solve that parallel branch. We're going to have to reciprocate those and get the answer for those two as well. So what we're going to end up with here is this. So these two right here are, circle that a few times, it's hard to see on my screen, are now this one. So the only ones that remain intact are the ones that were series all along, which was R1 and R7. Now it's just a matter of adding all three of these together to get that. So to review this, let me get a bigger pen here. The very first thing we did was solve this parallel branch. It went right here. Then we added these two together, which are in series. We added these two together, which are in series. And this guy right here, these two guys right here become this one guy. And these two guys right here became this guy. Then we ended up with this right here, these two that were in parallel, we have to solve those one more time. And we get this one, and then we add those three together and we got total resistance. So that's how it works, because this is a parenthesis within a parenthesis. This is another parenthesis, so we have to solve this first parenthesis first, add it together to that, add these two together, solve that parenthesis or parallel. I'm using a math term, but the essence is the same. And that's what you got.